First of all, I would like to thank you again, Rick Labuda, for inviting me for the second time to give this presentation. I'm glad and honored to share with you my researches and vision about Chiari I. Darwin wrote 166 years ago that a famous book called The Origin of Species, and because of that, everything has changed. I decided to divide this presentation in chapters. So I'm going to present 6 chapters, and each chapter is linked to one to another. The first chapter, introduction. Let's analyze this phrase. Hans is gone. This phrase is not complete because most of us would know why Hans is gone. He moved. He decided to become a monk, was kidnapped, arrested, murdered. By the same token, Chiari I is tonsillar herniation. And why? For more than 130 years, we didn't know the reason why. So Martians ordered it. It's a witch's curse. It's Neptune blamed the winds, Delphic prophecy. Or perhaps the answer is the long journey of human being evolution. Now, the two phrases are completed. We know that Hans is gone because he decided to become a monk, okay? And I'll try to convincing you that Chiari I is tonsil herniation because the long journey of human beings evolution. So let's go a deep further on the chapter 1 about Chiari disease itself. Chiari is commonly described as a 5 millimeter or more tonsillar herniation below the foramen magnum. So here we have the foramen magnum, and all these are the tonsils that had gone through the foramen magnum and is compressed the spinal cord, and the patient have a syrinx, a cavity that may give him symptoms. It's interesting that this dog breed also has Chiari I malformation. The prevalence is up to 95%, and 50% of the dogs have syringomyelia. And we know the man has been breeding and crossing breeding dogs for a long time. So here we have this spinal cord compression and syrinx in this kind of dog. In Brazil, it seems to have a high incidence of Chiari malformation in the northeast part of the country. And this is thought to be due to the colonization, the Dutch colonization that stood here for 30 years. And once again, is this disease caused by interbreeding in humans? The disease may cause a myriad of signs and symptoms. We know one of them, painless burns, because of loss of temperature sensation. Here we have a picture of the legendary Roman soldier, Gaius Mucius Scaevola. He's thrusting his hand into a brazier on fire to show his courage before the king of Etruscan. We suppose he had Chiari I malformation with syringomyelia, so he didn't feel pain at all when he put his hand over the brazier. We suppose the Chiari I malformation is, the problem is around the foramen magnum, and specifically around the clivus, sorry. And we don't really know why the clivus is hypoplastic. It's a premature stenosis of the sphenooccipital synchondrosy. It's a underdevelopment of the occipital somite. It's a problem of the paracardial plate. As a matter of fact, we don't really know. In this slide, we have the percentage of space occupied by the skull that we call the supratentorial space and the infratentorial space. They are separated, but a dura called tentorial. In normal people, the supratentorial space will have this percentage of the space occupied, and the infratentorial space will have this space occupied. In Chiari I patients, there is on average a loss of 5% of space below the tentorial region. So patients has a small posterior fossa. This volumetric analysis shows that patients with Chiari I have less space available in the infratentorial space. Okay. The infratentorial region is a funnel-shaped structure where the cerebrospinal fluid must flow through. It seems that in Chiari patients, this flow is rolling and not as smooth in a normal situation. And this turbulence causes compression of the spinal cord. Several years ago, chapter 2, I was asked to write a chapter about Chiari I malformation. And I realized there was no good explanation to its existence in the neurosurgical field. So the neurosurgical field was empty. I turned myself to the field of anthropology. Then I started to build a bridge of knowledge to cross the river of unknownness. Chapter 3, Paleoanthropology and Chiari I. It would be very interesting if you could go back in time to meet these hominid species that have striven in harsh environments and made it possible for us to be here today. Paleoanthropology changed from a descriptive and historical discipline to an analytical, genetic, and biomolecular one. Paleoanthropology studies the origin of hominid species, bipedalism, and brain growth. Genetic science now has sophisticated tools that can be used to map up our link to the past. So we have the several tools: mitochondrial DNA, Y chromosome DNA, X-linked DNA, autosome DNA, that can be used to link us to the past the hominids. And you know, by molecular anthropology, that humans, chimps, and gorillas have a common ancestors. And 93% of all primates species are unknown, and only 3 can be found as fossils. It's also well known that Africa is the cradle of humankind. And there are 3 models about the evolution of modern human beings: replacement model, assimilation model, and gene flow model. The last one is the most convincing of them, the gene flow model. This is the trellis model of recent human evolution. The Templo trellis model. Templo affirms that humans expand out of Africa, and that expansion resulted in interbreeding, not replacement. At least 3 out of Africa occurred instead of a single one, as previously thought. It can be deduced that allopatric population met and mingled in the last 1 million years. Well, brain evolution. We know that our brain is a nature's masterpiece. It's the most expensive body machine and is 5 times larger than predicted compared to other species. Probably the brain has grown five times in the last 5 million years. The reason of this massive growth are fire control, cooking, harsh environment, competitions, and the development of hand ability. Anyway, the brain had to count on 2 partners to grow, Calvaria and the skull base. Sorry. So the brain said to the Calvaria, Cal, let's grow. Cool brain, single mission. And the quite adaptive Calvaria said it was okay to answer this single request, sorry. And the Calvaria evolution was by 3 slightly different directions. In these directions that you call dolicho, meso, and brachycephalic. So these are the slight different directions that Calvaria had grown to get adapted to the brain that was growing as well. On this one, we can observe the vector's growth field all around the skull. But it's interesting that you have negative vectors in the skull base. I'll explain it better later. Anyway, the brain also asked the skull base to grow and walk. So the skull base said, ain't good brain, double mission. The Calvaria had 1 single mission, but the skull base had a double mission. And what did the skull base had to do to get adapted to this double request? I would call it skull base revolution makeshift. Because to get adapted to the request, the skull base has shortened its length to accomplish this double request. When the bone grows in its axis, we call this isometry. When the bone is bent, we call this allometry. So to accomplish the demand of the brain, the skull base suffered what we call allometry. The clivus was bent to accommodate the brain. So during evolution, we had a brain box that became a brain sphere. So we can see here this change that occurred in the clivus to get adapted to the brain demands. So once again, in the past you had a snout and a brain box, and now we have a brain sphere with a face. We see here that the skull base of the loris, chimp, and human, the difference of the length in the loris, the skull base is much longer than in human beings, and also the foramen magnum on this on the right part of the slide has advanced to permit bipedalism. This video compares the length of the endovolt and the base length. You can see the difference. So the skull base is much smaller in human beings compared to the endovolt length. So why the skull base length is short and sloped because you have a spatial packing problem, a sphere. Firstly, to give more room to the brain to grow, the brain became like a sphere because the sphere is the most space efficient 3D form. If the brain was too elongated, the cost of running it would be prohibitive. Secondly, the posterior fossa marked allometric changes, as commented before. And thirdly, foramen magnum advancement to give a fulcrum balance to permit bipedalism. Chapter 4, Clashes of Species. Chiari I is an intricate disease. Unlike many other diseases that have common and quite understandable pathophysiological rules, Chiari I seems to follow a rule of its own. So I start to wonder why this brain crazy desynchronization. Brainy, I can shout to you. The skull said to the brain, but the brain is skull, I'm bigger than you. How can you shelter me? So in Chiari patients, you have a brain that's bigger than the skull. And you can, so I start learning the different shapes of the skull of Erectus, Heidelbergensis, Neanderthalensis, and Sapiens. And you can see that in all these species, the basal angle has changed along evolution. And more angled the mean basal angle, more space available to the brain. If Chiari I has a rule of its own, maybe I suppose in my paper that allopathic populations met and mingled in the past, and that archaic genes of ancient hominids kept on living people still have these archaic genes. So perhaps Chiari I is a phyletic brain case mismatch. That's what I wrote in my paper. Anyway, when you have chapter 4, searching for footprints, when you have an hypothesis, we must find some clues. You must give it some support. So that's what I did. I studied anthropology for about 4 years, and it took me 2 years to write the paper because in the beginning, I didn't know anything about anthropology, just general acknowledgement. I was not aware of anything about the skull-based evolution, etc. So it took me a long time to write this paper, where I put my hypothesis, I forward my hypothesis on this paper. And once again, we see here pointed the tonsillar herniation and the syrinx in the spinal cord. Once again, in 2013, we presented this e-poster in the American Association of Neurological Surgeons in New Orleans, where we measured the angle, the basal angle that we call platybasia in Chiari, and compare it to a control group. So this is the material methods. The basal anthropological angle was calculated in 23 individuals with Chiari I malformation compared to 43 control ones. And you can see here, the Chiari group, the angle is about 142, but in the control group, the angle is 115. So much more angled in the control group. And the mean basal angle in the Chiari group was 122, in the control group 112, and this was statistically significant. Once again, you see this, the Chiari group, the angle is less sloped than the control group. We also published another paper in 2016. We had simulated posterior fossa reduction in Chiari I. And it's interesting because when you did this simulation, we found the same number of 5% less space available in the posterior fossa. So once again, pointed to the clavus shortness or the change of the angle that contribute to a smaller posterior fossa. Anyway, 12 years later, this year, we had strong evidence to support this hypothesis. This group made a test of the archaic Homo introgression hypothesis for Chiari I malformation based upon our hypothesis. And interesting that they found that the skull of Chiari I is more similar to the skull of Neanderthals. And they call these introgressor genes, and call this, and they supposed that Chiari I is linked to Neanderthal species. I believe that further direction is to study the genomic, make a genomic study of patients with Chiari I to find out the introgressor Neanderthal DNA related to its development. If somebody arrives to do this kind of study, we'll have a confirmation that the theory, the hypothesis is true. Well, chapter 60. This is my take-home message. We may view Chiari I linked to these 4 blocks. Corps inachevé, it means unfinished body in French. Applied anthropology, 3-piece puzzle, and clavus ramp. All, if you understand these 4 blocks, we understand Chiari, okay? So corps inachevé, I guess, is a French concept that everything changes along the time. We are always evolving and get adapted to new environments. The second block is that if we apply anthropology today, it may explain many diseases, and Chiari as well. Many diseases that plague population worldwide, like obesity, smoking, anxiety, etc. So applying anthropology might be a good thing to be studied and make us understand fully the diseases around us. So this is the second step to understand Chiari I. The third step is a 3-piece puzzle. We had the brain, the calvaria, and the skull base. All of them had to grow. It's okay. And the brain and the skull base has even growth, but the skull base in the region of the clavus had shortened instead of growing. So this is a key message. And once again, in the short video, we can see how the skull base has shortened its length during evolution. Sorry, I'll go back again. Okay. I'm gonna show you again the movie. So in the short movie, we see how the skull base has shortened during the evolution. Take home message, step 4. This is the last block, cleavus ramp. So Chiari I might express itself in 3 ways: a less sloped cleavus, a shortened cleavus, or a combination of less sloped cleavus and shortened cleavus. This is how the disease expresses itself. And that's why you have less space in the posterior fossa that cause tonsillar herniation and may cause symptoms, and patients may need operation, and sometimes sophisticated operation that you have to put screws to stabilize the spine and the skull base. I didn't comment about surgery because I guess it's not the point in this presentation. Anyway, my friends, I'm about to end this storytelling. Let me just finish it, saying that Chiari I is not a malformation. Even though I have said it before, malformation, I guess this term should be abolished, because Chiari is just an imprint of the long journey of human evolution. The skull base lagged a little bit behind during this race because the high complexity of bipedalism. That's it. Thank you very much.
Oh, thank you, Dr. Fernandes. Very interesting. Again, if people have questions, click your Q&A button and enter them in there. But I will get us started. Could you kind of clarify? It seems a lot of part of your message was a mismatch in evolution, and as evolutionary demands grew the brain, the top of the skull grew adequately, but the skull base did not. But you're saying that that did not because of interbreeding from Neanderthals. Is that correct?
Yes. Yeah. I'm not sure if it was Neanderthal, but anyway, because of this change of the skull base angle, if you have a little a cleavus that's short, or any change in this angulation, automatically you're going to have more or less space in the posterior fossa. And the posterior fossa is a very tight space. When I was resident in neurosurgery, I always learned that posterior fossa was a dangerous place to operate because the patient could suddenly die. And at the time, I didn't know anything about Chiari, but I realized during this research that this region is tight, even in people who don't have Chiari, because it was the last part that was developed. So it's a very tight space. When you work in this region in operation, we already know it. So I guess in every human beings, it's
so are you also saying that there's very little tolerance for those anatomic variations because it's naturally so tight?
Yeah, it's naturally tight.
Because one thing, Conquer Chiari has done a lot of morphometrics research, measuring the different angles and stuff. And we continue to find, clivus variations, of course, jumps out. But the question is always, is it enough to actually cause a problem? Because in an absolute sense, they seem like really small variations.
Well, I believe so, based on what I studied in my research. We're never sure about anything in life. I mean, we have to speculate it.
Yeah, no, I understand.
The hypothesis. But I guess yes. If you lose 1 centimeter, or if the angle changes 1 or 2 degrees, I guess it's enough to cause the problem, in my opinion.
And what role do you think the environment plays in other words, do you think a lot of people can be like this, have this type of anatomy, but may never become symptomatic? And is that because of environmental issues of some versus the other, traumas, microtraumas, things like that?
Well, I'm not sure of that. I never read anything that pointed to that, but obviously the environment plays a role. in many diseases and might play a role in Chiari as well. But I guess this is more, how can I say to you, something that we inherited. It's from our past genes. So I guess even everybody carries these genes, and they are activated somehow in Chiari patients. But I guess everybody has ancient genes, and it would be very interesting if you had this genomic study of patients with Chiari I compared to people without Chiari, and to discover it.
Right, right. All right. Someone asks, in your opinion, as a surgeon, can you explain why Chiari results in so many different symptoms?
That's interesting. I don't have a good answer for that, because it's a myriad of symptoms and signs, and sometimes we are in doubt if it's all of these symptoms and signs are really related to Chiari I. In very how can I say, in patients who has a huge syrinx or a skull base that is very distorted, it's okay. But sometimes you see patients with mild Chiari I, and they have symptoms that do not correlate to pretty well with the images. That's true. Well,
okay, but I mean, well, in one sense, though, it can almost be expected that there would be a number of symptoms because they could be related to compression of different components, right, of the brain, the cerebellum, the brainstem, or the upper cervical spinal cord.
Yes.
And each one of those areas can manifest differently in terms of symptoms. So the brainstem, you could get autonomic dysfunction, right?
Right.
Yeah.
Because it's tight, huh? It's already tight in everybody.
Right. So it's a very important area. That area right around the foramen magnum is very important in a lot of biological processes. So the disruption, the compression and the disruption of the CSF, it's almost a roll of the dice then in different patients how it emerges and how it's seen.
That's why you're right. That's we divided the skull in supratentorial and infratentorial space, because in the supratentorial space we have much more space to work on as surgeon. In the infratentorial space, you don't know, but you have only 6 centimeters below this region that's called inion. I don't know if you know. If you put your hand in the inion,
the bump,
and below,
the
bump, below it, three finger breadth. It's the posterior fossa. So it's a very small space. Sorry.
Right. Okay. Does anyone else have any questions? Wow. Okay, this is a tough one. That's an excellent question, but very difficult. How do we get better data on Chiari I in Africa, which could be critical to testing this hypothesis?
Oh, well, I would not know how to
well, would you agree with the premise? Would you agree with the premise that collecting prevalence data in Africa would support this hypothesis?
Yeah, I would say so. It's a very good question.
But of course, going into countries where imaging is not prevalent like it is in industrialized nations makes it extremely challenging.
Yeah, it'd be very, very difficult to do that. But
so, what do you see a role with just the basic 23andMe and these other genetic companies that'll tell you your percentage of Neanderthal genes? In other words, would you hypothesize that if we took a study sample of Chiari patients and a ethnically matched control group, that the Chiari population would have a higher Neanderthal genes?
Yeah, I think so. I absolutely think so.
Because that's certainly a study that could be undertaken.
I guess you can do it. I cannot do it in Brazil because
I just meant technologically. Technologically, we can do that.
Yeah, all my research I did with my own money. I never got money for agencies because I hate paperwork, and as I hate paperwork,
so
I never get.
Back on the Africa topic. South Africa has MRI machines, presumably. Probably international research is extremely difficult.
Yeah, I guess.
So I just wanted to one thing I wanted to emphasize that I'm not sure was clear in your talk, and I'm certainly Mark can pipe in as an anthropologist, is that anthropologists use the skull base to identify the different hominid species, correct?
Yeah.
Like that's one of the major tools they use to identify.
Yes, because of the basal angle, they call it
Right.
anthropological basal angle. I learned in the neurosurgical field that we call it this anthropological angle was called platybasia. That's the word that I learned, and that's interesting because nobody made the link between platybasia, the anthropological basal angle, with Chiari. That was the hint that I had in the beginning of my research.
So there's a comment from Mark Kane, who is a patient advocate, that they had an Africa presentation and believes there are thousands of untreated cases in Africa, and that Western medicine is generally not trusted, which would make the research even more difficult. Here's another question. How is the evolution of the spine's position from Neanderthals to people now affect Chiari malformation? I'm not sure.
I'm not
Go
sure.
ahead.
I'm not sure I can answer this, but the problem is that it was the balanced fulcrum that the foramen magnum has going from back to the front. That's why the length of the skull base has changed a lot to give the possibility of horizontal gaze and made it possible to be bipedal, and that was a game changing. And yes, I don't think there's a big difference in Neanderthal and even Homo erectus as well.
Right, so Mark chimed in and says there's no big difference between Neanderthals and us in terms of bipedalism.
Yeah, I agree.
It's great having two experts on the presentation. So let me ask it this way, because I know what the data is in the US. In your practice, in your experience, how do you frame it to your patients going into surgery, what they can expect after surgery?
Most of the time, I reserve surgery only for patients who has syrinx, cavities in the spinal cord, because of most of the time we have Chiari malformation, Chiari, with no specific compression of the spinal cord. So most of the time I do not operate. I follow the patient during 1, 2, or 5 years to see if they really need a surgery. So this is quite different what I learned in the past, because in the past we learned that you should operate everybody, and things changed along the way. So most of the time I just reserve surgery when I have a cavity in the spinal cord.
Okay, so you're right.
I'm very restrictive.
And certainly once someone has a syrinx, there's a good chance they're still going to have deficits after the surgery.
Yeah. I even have patients with syrinx that didn't want to operate, so I still follow them, and they're okay. They are doing fine.
So is the syrinx stable, or I mean, if the syrinx is growing, you would strongly recommend surgery, I assume.
Yes, but sometimes patients don't want it, even if it had changed, it had grown, and it's okay. They are not so bad at all.
Some people have hypothesized that the syrinx is actually a compensatory mechanism that develops in terms of trying to alleviate the CSF pressure spikes. Do you have any thoughts on that?
Yeah, this is a very complicated issue. We don't know why we have this syrinx formation inside the spinal cord, even sometimes very away from the foramen magnum.
Yeah.
And perhaps the explanation that I showed you, the rolling movement of the CSF fluid might explain it, but it's quite difficult to understand the syrinx. I didn't find a good explanation for it until now.
All right, our good friend Mark has a fascinating question. Is there an opposite condition to Chiari I? That is there a medical condition associated with having a hypermodern human-shaped basicranium? We have found opposite conditions with vertebral conditions.
The opposite of Chiari?
Can you have a hypoplastic cerebellum?
Yeah, we have hypoplastic cerebellum, but these are generally linked to genetic diseases.
Right. That's truly more a brain development issue, though, right?
Yes. You have a virus and infectious disease that may cause cerebellum hypoplasia. We have a condition called let me remember the name, Dandy-Walk syndrome, that you have a very small cerebellum. I guess it's an issue that's not related to Chiari.
Right.
It's another condition.
So let me ask it this way: if we're talking about the skull base, then is it at all pathological to have a clivus that is 3 millimeters larger than average instead of 3 millimeters smaller than average?
Well, if it's pathological, I guess as long as you don't have problem, if not pathological, but as long as you have tonsil herniation, because it's interesting, because if you have 4 millimeters of tonsillar herniation, it's not Chiari.
Wow.
So it's not a big it's not a good answer. It should be 0. Right. We should say that 0 is the maximum. 1 millimeter is already Chiari, but the radiological finding say that's 5 millimeters.
I'm going to say to Mark that in my experience and research, I'm not aware of opposite conditions idea. I'm not aware of any type of opposite condition in terms of the clivus. I guess you could have the clivus too vertical, right? That's also considered. In other words, the basal angle is a range, and you can have a clivus that's too vertical. Yeah. But is there a specific name for that?
I don't think so.
Yeah, I don't either.
We don't see clivus like that. Very, very upright. How can I say? We have also this angle. It's always angled because clivus means ramp in Latin.
Right.
So we have this ramp.
Slope, right, yeah.
Slope, yeah, ramp, slope, okay.
So the question is, why are there not a lot of doctors that treat Chiari? So there's a limited number of, the primary treatment is surgical. There's a limited number of neurosurgeons given the training involved. And the majority of neurosurgeons, at least in the US, I assume it's the same in Brazil, tend to only operate on the spine. So even within the neurosurgical field, it's a subset of that will operate on the brain. So in the end, there are very few choices. There are very few doctors out there, especially if you're in a rural community. It can be very difficult to find one.
Yes, and it's not a common condition as well. So people might not have good experience with it.
Right.
I work at the University of Campinas and the public hospital, so I had the chance to see more patients with advanced forms of Chiari during my time at the university. So most of the neurosurgeons in their offices might not see as much cases as I did in my life.
Right. All right. I think we're going to wrap things up. We're getting close to an hour here. Thank you so much again, Dr. Fernandes. It is fascinating, and Conquer Chiari will factor this into. We received an award to develop a strategic plan for Chiari research. So we will factor this into developing our strategic plan, and we appreciate it. Thank you, everyone.
Thank you for the invitation. I hope to see you soon in Akron or any other place.
If you're ever in the States, let me know.
Okay.
Thank you
Thanks a
so
lot.
much. Thanks,
Bye-bye.
everyone.